So this is going to be the video tutorial on how to make a LCD sound counter specifically for the Stampede, but you can put it on anything that you want. And here it is what we're making. It's an Arduino based solution with an LCD and a sound speaker, and essentially it's that. I'm going to show you how you move the toggle switch inside the gun to make it actually work in a Stampede as opposed to a traditional trigger setup. I'm going to cover the Arduino and some Arduino basics so you can see how to wire it up and go in and do anything you want. The really cool part about this, in my opinion, is since it's a $10 Arduino 80 mega chip, which is incredibly easy to code even if you've never done any hardware coding before, is it's fully customizable. You don't like the sounds? Change them. You want to put in a toggle switch for the LCD? You can change that. You want to have a reset on your mag drop? That's easy. You want to add in more buttons, more features? Really, it's up to you. And since the base level coding and the base level function is all there, it's really easy to make changes. So let's start by looking at how we add the toggle switch to count the action to know when a dart has been fired. Okay, so here we have the run-of-the-mill modded Stampede. What's important here is we're going to reuse this particular toggle switch right here to watch and catch our events on the action, so when we know a dart's actually been fired. So what you'll need to do is, if you haven't already bypassed this annoying toggle switch up here, as you can see it's done here, is you'll need to cut those two wires there, and then we need to remove this toggle switch. There's just two screws holding it in. So go ahead and take that out. Now this is not needed. All it is a simple check to make sure you have a magazine in. There's another one over there. Yeah, I think there's just two there. It's basically to make sure, you know, a 6-year-old playing with a Nerf gun doesn't stick his hand in there without a magazine, pulls it, and have the action hit his hand. Same reason they have this annoying cover check that comes loose. We don't need it. So, assuming you've clipped the top two wires, or if you haven't, pull this out, and you're going to see a whole bundle of wires going on here. Now, these are toggle switches that are naturally open, and when they are pressed down, as in there's a magazine inserted, or in the case of the one up here that we've bypassed, when the slide's been pushed forward, it makes sure those are in place, so it completes the circuit, and that allows, I don't know if it's a transistor, an opto-isolator, or the voltage actually flows through, but basically all of these switches have to be closed in order for it to fire. So you'll need to cut these. Try to keep as much wire as you can without making your job too difficult. I mean, if you want, you could actually unwrap that, use all that wire, and then take care of it here. But the important part is after you cut these, you have to recomplete this circuit. So just crudely strip these together. Take your two wires, twist, make sure the circuit is complete, or the gun will never fire again. Actually, that's not really staying. You cut them longer. I'll probably throw a drop of solder. You don't have to. Just make sure it'll never come loose. So go ahead, remove this toggle switch, and make sure that this is closed. This is a closed circuit there. Just go drop everything here. Okay, now that we have removed the switch, it's time to place it somewhere in the blaster where the action will hit it. Now, honestly, if you can find a better place, put it anywhere you want. The only criteria is somehow when the action moves forward, it needs to be pressed one time. Now, if you're dealing with a non-automatic Nerf blaster, you know, you'll see people mounting stuff where they'll have a switch that's pressed in by the button, or there might be some kits out there. In the case of the automatic, if we pulled the trigger down, it would keep firing, and that would only register as one press. So it has to be something that happens when the action comes forward. I mean, I've heard of some people putting some stuff here or something anywhere where the moving action is going to press it. Now, what we found that works, and played with it for an entire HVZ game with really no problem at all, the one I just demoed, fired it, and it continues to work with this toggle switch, is putting it in the area up here. Now, you can see I did go ahead and just take a pair of side cutters and trim away a little bit of the top up here. You may not have to do it, but what you're aiming for is if you take this switch with the PCB board to the top, it's going to rest in about just like that. Now what you'll look for is, if you look at the top of the guide here, you're going to have about 5 millimeters or so of protrusion past that. That's kind of your frame of reference. We did actually end up mounting one farther in to test, and the force of impact from the action actually broke the toggle switch. So once that's in there, what you want to do is, actually kind of stick pretty nicely there, is you want to be able to press on the toggle button itself. Of course, it's difficult. And you want to make sure, you can see that I'm pressing it, it's not binding. As you can see, removing a little piece there most likely helped. Just like that. Once you have that in place, we've just been using hot glue. So go in with some hot glue, go around, support it, get it there, do the bottom first, let it set, then don't go too much. Get it so where it's secure, and then once we know it's set, it's working, we've tested it, then you can go ahead and add more and solidify its place with it. So in case there's a problem, you don't have to go in and remove a bunch of hot glue. Also, I don't think there'll be any problems if you actually wanted to trim more of this piece out here. I just don't want to dull my side cutters up anymore if I don't have to. As long as you don't go crazy, you should be able to trim a good amount of it and not really impact anything there. So that's how you mount that. You probably want to go ahead and get these leads ready. This is going to be your toggle switch. Before you install it too, you can actually lengthen these wires, because that's going to go back to our Arduino and connect up there. Also, as you can see here, I went ahead and put the solder and tuck this wire away. So now that that's settled, we'll go on. We'll talk about the Arduino, how you install it, how you do a basic setup, and how you configure the basics. Okay, now on to the microcontrollers, specifically Arduinos. If you know how to use them, you know how to program, you're probably not going to get anything out of this. Just go to the website and download the code for what I have, and you'll be able to run with that. I will hit some basics here. If you want to know, forgive me, but if you don't know, it'll be a good way to get started. In a nutshell, an Arduino is a ATmega based microcontroller that allows you to control digital and analog pins, input, output, read circuits, turn things on, do very neat things. What makes it neat is the compiler for it is not written in very hard to code assembly. You don't need any degree to work one of these. You just need some basic programming knowledge, and if you don't, Google's pretty helpful. So it's a very C-like language. It's very easy to use, or at least easy to learn. I'm not even a programmer. I'm not an E major. I'm a networking person, and I can do this. I could come from a Perl scripting background, so this wasn't hard to pick up. So this is a standard board. Here's a Arduino, one that plugs in. You can use any Arduino you want, as long as it has the basic functionality. What I recommend is the Arduino Mini Pro. As you can see, it is razor thin. In fact, the header is huge on it. It's $10 on SparkFun. Don't even tell me about 555 timer when this has gotten so cheap. And you can use this to do this basic stuff, and you can add on other stuff. You can add on lights, you can add on more sensors, more function. You can put an RF chip. on and on. Very easy to add more stuff on and do other cool stuff with. So let's get into how this is going to work. So basically, for requirements, you're going to need at least an Arduino and an LCD display if you want to use that, some sort of speaker, a little piezo speaker, at least one resistor, and if you want to add a reset switch, any sort of switch. But there's no limit on what you want to go. You may want to add a power switch, toggle switch. The base code I'm going to get is set up to use the toggle switch we pulled out here to count darts, a simple switch to reset, and a speaker, and this serial display. We're using this display here, actually has an ATmega on it, because we can send commands to it via serial as opposed to turning on each individual segment, which could be done with shift registers and such to work with our limited number of digital output pins, but it would just be a wiring mess. And the wiring is already kind of messy, in my opinion. I think this is $12. This is the most expensive part. But it just makes it so much easier. So $10, $12, $1 at 10 cents, $1, you're looking at about 25 max. So let's go into how we're going to connect things. Okay, and I will post a board layout of connectivity on the website. But here's basically how it's going to work. You're going to have your Arduino, represent with this box here. For our setup with two switches, a toggle switch and a reset switch, serial display, and a buzzer. How this works is you have, let's see if you can see them, digital output pins on here that are numbered. We're actually going to use two specific pins for these two buttons for a reason I'll get into later. The code example, the toggle switch here, is going to use pin 2. So this represents pin 2 right here. Pin 2 is going to come out with a wire. Here's our toggle switch. On the board you'll also find a 5 volt, or it should be labeled on this VCC, because this is a 5 volt board. It's actually over here. So that's 5 volts. That's actually going to come out and connect to this part of this toggle switch. Then pin 2 will also connect in right there, but also there is a ground pin here, and that is actually going to connect in somewhere in between, and then your resistor will sit and connect like that. Now what's happening here is we tell the code to look for watch pin 2, and if pin 2 goes in Arduino language or microcontroller, I don't know, high, I mean it has voltage, take an action. So this circuit is constantly open. No current is passing through. Forget about this ground for a moment. Then, so this 5 volts coming all the way, stuck here, can't get across this physical bridge. When this is depressed, the current is allowed to pass over, and it goes through, and pin 2 says, oh, I see 5 volts. So something happens. Let's do whatever you want to do. You've just triggered something based on a mechanical action. Simple, makes sense. However, since the digital I/O pins and the analog pins are so sensitive on the Arduino, interference, noise, other things, if you just had it set up like this, would cause it to see noise and maybe make it think pin 2 is high when it really wasn't, because it's actually low, nothing's happening in, but just RF interference, radiant noise from another pin will occasionally spike across and make pin 2 think it went high when actually nothing happened. So that's why we connect this ground across and it bridges in here. And the resistor is important so you don't fry the pin. So what happens here is, so when this switch is closed, pin 2 is constantly seeing the negative ground, keeping it low at all times until the switch is depressed, and then you have 5 volts coming in. So this is how the wiring kind of gets messy. It's really easy to do on a breadboard, but look at this simple picture here and you'll see the diagram. Just the ground comes in, resistor, and it ties in like that. And actually you could tie it in there, just anywhere on this side of the circuit. Doesn't matter, it's going to be whatever is the easiest to wire up. You know, you can bring it in there. You're going to use your ground in quite a few places, so you find yourself having to branch it off. It might even be easier if you can fit a breadboard in there and just pin stuff in, as long as it's not going to vibrate out. So then we're going to have our reset switch, and he's going to live right here for sake of example. He's going to go to pin 3, and the same thing's going to happen. You've still got this 5 volts. Well, you just peel off him again, because you know you can't really run another wire from that pin, and he's going to connect there on one spot, and then he's going to connect into pin 3. So when he's depressed, boom, 5 volts across pin 3, he goes high. However, we still have to bring the ground around, that's whatever the step over symbol is, with the resistor, and connect him into that. So you can see the more switches you add, it's a little bit more messy to actually wire up. And that covers our 2 basic switches. So if you were going to actually cover in your magazine switch, instead of putting the reset, or you may still want the reset, you'd actually go find the second toggle switch inside the Stampede and pull those wires and make that toggle switch, leave it in the reset switch. You'd have to play with the logic a little bit to make that work. Then real quick, so you have our counter, this particular display, which I will provide the code for. If you want to do something else, you'll have to code that or figure out how to make your own counter 2-digit display work. It's really simple. It has, I think it changed a little bit on the newer model, but basically it has a voltage in, ground, and then signal. So whatever, I think pin 5, say it was pin 5 we defined here, or this will be pin 9. That's going to come out, connect into here. Oh, by the way, pull that same ground into ground here. No need for a resistor. And pull that 5 volts across and plug him into there. That provides him power, and this provides him with his signal. The speaker is probably the simplest of the most. It has a positive lead. See there, they'll all be different, but it's directional. Oh, you can see there. So it has a positive and a negative. So you'll take a ground pin, that's our speaker here, that's our negative, that's our positive. The ground just has to plug into any ground. You don't have to put a resistor on this. And then the positive is going to plug in to, let's say pin 9. And basically you'll tell it to play a tone. You'll say play a tone on pin 9. Positive to the negative, and that gives you sound. That's if you want a speaker or not. But on the basic level, all you need is this. If you want sound, if you want a display, you add those things. So finally, I want to talk about what's Hapcode and the 2 different ways you can do it. Arduino basics, again, most of you probably know this, or if you don't know about interrupts, it might be useful. Is you have a primary loop that runs, and basically what happens is the controller, once you do all your setup and stuff, it runs this loop over and over and over again. In a traditional sense, you may have a subroutine, like a dart shot, and basically you want to call this subroutine, and over down here in the dart shot subroutine, you say read, stop writing all this out. Tell me the status of pin 2, and is pin 2 low or high? Well, pin 2 is only going to go high when a dart's been shot or the action has come forward. So you say read pin 2. Okay, pin 2, is it high? No. Well, then you just continue looping through la da 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 till finally the instant that pin goes high, because the action came forward and closed our switch, it says, oh, pin 2 is high. Okay, then you can say, well, take your whatever you're using to count your darts, take that, subtract 1. So in my case, it's hard-coded to 18 right now. It's now 17. Then once you've done that, go back to your loop. I'll check, just like that, and that's a pretty standard loop. The limitation here is this loop is a time-based event, and with the speaker and delays, you interfere with that. So if we had, as you saw when the gun fired in the demo, we'll call it a function called sound, goes out, and sound is down here. Sound says, you know, play tone 400 hertz for 300 milliseconds. Then I want you to wait for 600. So that gives you a beep, beep. And as you saw in the code that I gave, it increased the intensity, kind of like, okay, you're getting lower and lower. And again, you can change all that. The problem is in this setup here, in this main loop, this won't work, because what will happen is once you come into this sound routine, you have 300 milliseconds here, 600 here. That's almost a second where you're going to be sent either playing a tone or processing. This is not a forked process. This doesn't go off and happen and you return to the loop. You are stuck in this subroutine until this is finished. So what the problem would arise would be that is you've shot another dart, and almost the whole second you've wasted trying to create this cool sound effect here. Now, obviously, you could just not do any of this. That's actually how we originally contrived it. And then we realized, well, wait a second. What we can do is pretty simple, and it gives us these cool dynamic tones that we can change. So how the code I'm going to give you is set up, and why I have you use particularly pins 2 and 3 is the Arduino has what are known as interrupt pins. And these are true hardware interrupt pins. So what happens here is you're not going to see a dart shot in the main loop. You will see a sound. What happens is at the top of the setup, we make a statement that says, hey, if interrupt 0 or interrupt 1, which corresponds to pins 2 and 3, it's a little weird, if they go to high voltage, I want you to immediately call the subroutine dart shot. And then what happens is, so we're processing sound, blah, 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 we're stuck waiting for 4 seconds or, you know, whatever you wanted to do. Doesn't matter what's going on, how many delays are being processed tones. When any of those 2 pins meet our criteria, they're interrupted. They stop. You stop processing whatever you're doing in this loop, and then you call the subroutine what you wanted to do, which is dart shot, which we don't even actually have to read a pin. We could if we wanted, but we already know something happened. And then we say, okay, well, the dart counter is now dart counter -1. And we go from there. And then we can continue to have weird long tones and delays and processes functioning exactly as we want. And it's also useful in systems where you're doing a query on a analog pin or a digital pin, and you have time sensitive. When you're running a counter, you actually see some drift and delay when you actually stop to query something, however fast, you know, this loop continuously runs. So this is set up to run on an interrupt-based system. You can convert it back to this. You'll have to get rid of the tones in between. The final note that you saw, the da-da-da-da-da beeping sound, is actually 100 milliseconds each. And actually, if you press the reset switch in the current state of that, and you hit it during 100 milliseconds, it won't do anything because it's stuck. But since that's so fast, that's never been a problem. But to add the more dynamic tones, we switched to the interrupt-based system. And finally, probably the coolest thing about this is you just put an Arduino on there. You're going to use maybe 3 of your digital pins, leaving many, many more in analog pins. You can add so much more cool stuff. An RF chip, more LEDs, you know, anything like that, or something I'm currently working on. I have an old drum that's broken, and this here is a stepper motor. Stepper motors can move very precise amounts on command. So you see where I'm going here. We know when the gun has pushed the action forward. We can then tell, simple addition to an Arduino or subroutine, oh gosh, you fired the gun once. turn this the exact amount to feed one dart in up to the top, and then stop. And don't do anything until we tell you to do something again. You have in concept here, excuse me, a drum or a magazine or a feeding device that will only feed as fast as it necessarily needs to. So you will then theoretically have the fastest rate of fire that's even possible. You could even go crazy and, you know, cut off the top and create a kind of a hopper-based system where darts fall in there. You know, you have to get creative with that. But you could create a cooler loading system because you're no longer relying on a simple spring to load this system. And again, this is just a cheap stepper motor. It takes a stepper motor driver. It's just one of the many things you can add to your Arduino system once you have it in place. It's really easy to add and works. You know, it's piece of cake. So the website munerfmods.blogspot.com will have the code and a few details. If you have any questions, you can email us. We'll do our best to help you troubleshoot. But good luck.